what is the connection between giant hail events and marine heat waves? Hello, friends. Jim here. Well, recent studies showed that Spain's giant hail event was made worse due to marine heat waves. And here we see a photo of I'd say a rather substantial size hailstone. That will certainly punch a hole in your windshield. And what we see over here, ooh, look, the Mediterranean. And look how hot it is. It's like off the charts. We'll look at this diagram in a bit. So that's a giant hailstone pictured in Girona, Spain during the 2022 event. Hail, well, depending where you live, you can get hail in wintertime, sometimes in summer. And typically it's short duration, intense, and you just get a whole pile of them. And, the event's over and onwards and upwards. Well, on the 30th of August, 2022, Girona, which is in northeastern Spain, it experienced a severe event in which individual hailstones reached a massive 12 centimeters in diameter. That's about, not quite, that's like 4.5, 5 inches across. This led to serious damage to buildings, cars, agricultural areas, 67 injuries, and 1 fatality. So, new research published in Geophysical Research Letters, Professor Maria Luisa Martin of Universidad de Valladolid, Spain, and her colleagues investigated the role of the record-breaking marine heat wave had in exacerbating the hailstorm. The Iberian Peninsula experienced a sea surface temperature increase of an average of 3.27 C protracted over 6 weeks in the summer of 2022, highest on record. The research team found that atmospheric convective energy reached unprecedented levels, thus alongside moisture from a warm ocean, enhanced supercells, right, storms with a vertical rotation of rising air currents, that developed in the Pyrenees, and it led to this massive hail event. So they examined a data set of more than 280 documented supercells from 2011 to 2022, with 57 citing large hailstones more than 5 centimeters in diameter and 4 giant hailstone events where they exceed 10 centimeters in diameter. So they used that data to simulate the hail event both with and without the influence of a marine heat wave in the Mediterranean Sea. Increased sea surface temperature is known to be one of many consequences of global warming and has a direct impact on the frequency and intensity of prolonged heat wave events. Don't forget, oceans are absorbing over 93% of the heat energy humans have introduced to the system. And here's a map showing the locations of some of the hail events and the frequency. So you see green is about 3 to 4, and this is, hours in duration, all the way up to this red dot here of, about 7 to 8 hours. And they give you the lat long locations. While hailstone events seemingly sporadic, the simulation determined that large hailstorm could take place for greater than 4 hours per year. The Maestrazgo region of northeastern Spain was shown to be the most susceptible to these large hail events in the country, as is it a focus point for supercell formation. As we'll see later on, this is where the hotspot in the Mediterranean was found, so it's right there. Furthermore, the warmer Mediterranean Sea is determined to be a factor of anthropogenic induced temperature increases, an additional variable included in the simulations. Modeling a pre-industrial climate, marine heat waves were deemed to be significantly less frequent and severe, therefore highlighting the role global warming has on extreme meteorological events. Indeed, some of the most severe hailstorm events on record in the dataset occurred within the last 3 years up to 2022. Overall, Professor Martin and the team identified a significant reduction in conditions conducive to a hail event when marine heat waves were removed from the models. Specifically, a decline in convective energy and weaker updrafts, hindering supercell development. The research is important as it is a cautionary tale of how continued climate change will not only increase the likelihood of marine heat waves, but also other elements of Earth's interconnected cycles, teleconnections, the interactions between ocean and atmosphere. Consequently, there may be more unforeseen meteorological events to come with alarming environmental, social, economic impacts. So let's take a look at this here. Right, there's a nice look at that. And here's a coin there, obviously for scale. And sea surface temperature, we can see X marks the spot for that's Girona, Spain, presumably. But look at how hot that is. Now, the sea surface temperature percentile, this is basically off the charts. That's what this is telling. This is off the charts. Here's the anomaly. Here's the anomaly. Look at that. This is incredible. You know, I just did the recent ocean heat update video where I discussed what was going on in the Mediterranean. In fact, you know, the transect that the researchers utilized was basically occurred right in this area. And I showed how the warmth is penetrating down to 400 meters. There's a lot of energy stored in the oceans. And it's coming back. It's coming back to us in the form of nasty precipitation events, increased air temperatures, prolonged heat waves that last longer, hotter, cover a larger area, fueling more violent cyclonic storms, melting the sea ice. That energy is starting to be returned. It's not going to stay in the oceans. And this is just yet another example of how this is all happening. There you have it. Until next time.